Let's talk about graphing the standard form and the vertex form of a quadratic. So we know the standard form of a quadratic is y equals ax squared plus bx plus c. And a, b, and c, those would all be numbers when you're actually looking at an example graph, and you would just see the x and the y variables in your equation. So what we're going to do is we're actually going to go and look at Desmos, and we're going to graph this to kind of figure out what A, B, and C do to that graph. So you can do this along with me on your computer, or you can watch along if you'd rather do that. But we're going to type in y equals ax squared plus bx plus c. And it's going to ask us to add a slider for A, B, and C. And we're going to go ahead and do that. And right off the bat, you can see that we have this shape here. And every quadratic has this shape. We call this a parabola. So what we're going to do is we're going to look at what A does first. So we're going to move the slider for A, and you can see that right now it's at 1. And as I move to the right with this slider, if it's going to let me, if I move it up here, look at how the graph is gradually getting skinnier, but it's still opening up. And if I move that slider down, so let's see if I move it down this way, look, all of a sudden it has flipped over and that parabola is opening down. And we can see that that change happens from when A is negative down here versus when A is positive. So those are some conclusions that we want to finish on our worksheet. So going back to that worksheet, it says the shape of a quadratic is, so we're going to fill in a parabola. The shape of a quadratic is a parabola. If A is greater than 0, then we know that that parabola is going to open up because it's positive. So we're going to write up here. Let's see. And the graph, when it opens up, so when it has this shape to it, it has a lowermost point right here. So we can say that it has a minimum value. So it looks like my pen doesn't want to write here. So go ahead and fill that in with minimum value. And if A is less than 0, the parabola is going to open down. And the graph in that case, like the one we have pictured here, it would have a maximum value because it has a topmost point right here. So let's go ahead and fill those in. I'll pause and I'll fill those in for you. So we figured out what A does. Now let's take a look at C. So if we go back to our graph, right now we can see there are some points here. I'm going to put this back at close to 1, just so it's a little bit wider so we can see what's going on. But one thing that I'll notice as I move C, take a look at what's happening with your y-intercept. For example, when C is, if I move the slider to 2, notice my y-intercept right here is 2. If I move C down here to -5, I can see that it's at negative 4.9 is what I have for the slider. And that's regardless of if A is positive or negative, that's still going to be my y-intercept. So we can go back over to our notes and we can fill in C is the y-intercept of the graph. So the last thing that I want to do before we kind of practice with this on Desmos is I just want to label some major parts of our quadratic. So we talked about how there's this point up here where the graph kind of changes, basically if it's going from up to down or down to up. We have a point up here, and this point is either the minimum or the maximum, but it has a specific name, and we call that point the vertex, okay, V-E-R-T-E-X. So it's the vertex. Then we know that this point here, that is your y-intercept, so that's what we just wrote here. So the point that crosses the y-axis we know is our y-intercept. And then we also have 2 points we can see here, and it's not always going to be 2 points. It might be 1 point or it might actually be 0 points. But in this case, we have 2 points that intersect that x-axis, and we call those the x-intercepts. Okay, so the x-intercepts. You'll also see this dotted line here that kind of splits that quadratic right down the middle, and we call this the axis of symmetry. And we know what symmetry means. It's if I folded right along that axis, the left side would fold directly on top of the right side. So it's the axis of symmetry. So I'll just kind of abbreviate here. So we have the axis of symmetry. Okay, so let's get moving forward with this. It says graph the following quadratic on Desmos and copy the graph below. To make your graph as accurate as possible, we want to label at least 5 points, and that includes the vertex and 2 points on either side. So we just want to make it a nice large graph and as accurate as we can make it. So I'm actually going to pause it. I'm going to go ahead and let you pause the video, and I want you to try to do this on your own. So go to Desmos, type it in, and see if you can fill in as much of this information as you can, then come back. So I have it graphed here in Desmos, and you can type in f of x equals, or you could have just typed in y equals, it doesn't matter. And if you want, you can zoom in or out on this graph to focus on different parts of it. You can trace along different points to see different things. But let's go ahead and use this to fill in all that missing information on our worksheet. So let's see, what is it that we're being asked for? It looks like we want the vertex, y-intercept, and any x-intercepts. So if we look at our graph, the nice thing about Desmos is you can use your mouse and click anywhere on here to find a point. And it kind of holds steady on the 0.45, and that tells me that that's our vertex. So we have a vertex at 4,5, so let's write that on our worksheet. We have down here, I can see these points already. We have the point 0, -3, so that's going to be our y-intercept because it crosses the y-axis. And then we have these 2 points right here, which aren't at integers, and that's okay. That's going to happen fairly often, but we can use those still as part of our information for when we transfer this onto our notes. So we're going to go ahead and put all of this information onto our worksheet. So I'm going to go back to that and write that down. You should do the same if you haven't already. We have those on our notes now. We want to create our graph, and we also want to evaluate the following using Desmos. We want to evaluate f of 8 and f of -9. So I'm going to show you how to do that. So there's a couple of ways. We could scroll around using our mouse, moving this around, trying to find, well, here's where -8 is, here's where 9 is. Those are it, right? I just want to make sure. 8 and -9. Okay, so I got to go backwards. So 8 is over here. So we can see here's where I plug in 8. Well, I can see that it looks like it crosses at -3. And when I click there, I can see the point 8, -3. So that means that f of 8 equals -3. But if I weren't quite sure if it really crossed at exactly -3, something that you can do, and let me move this out of the way, is you can come over here and you can click this little gear button, and you'll see a table show up. And if you wanted, you could convert this to a table, and it's going to take the graph that you created and make a table using that function. And then you can edit the x values. So if I wanted to plug in 8, I can just type over it, and I can see the f of x value changes to -3. And if I wanted to see what -9 is, well, I can plug that in, and I can see it's -79.5. So we can go back to our notes and put that in. So the last thing you need to do is just create your graph. And if I were you, what I would do is I would plot the vertex at 4,5. I would plot the y-intercept at -3, and because it's symmetric, looking at this graph over here, so we have this point over here at 0, -3, well, because we have our axis of symmetry right down the middle, that's 1, 2, 3, 4 units to the left of the axis of symmetry, and let me actually just graph the axis of symmetry so you can see that real quick. So you can see that from the axis of symmetry, you have a point 1, 2, 3, 4 units to the left. So you would also have a point 1, 2, 3, 4 units to the right, so that point 8, -3 there. So you could plot those 2 points along with the vertex. You could plot your 2 x-intercepts. You could plot, for instance, here's a point right here at 2, 3. That's 2 units to the left, so 2 units to the right. That would be another point at 6, 3. So just plot whatever points that you want, and then let's go ahead and move on to the back. And now we want to take a look at vertex form of a quadratic. So y equals a times the quantity x minus h squared plus k. That's the vertex form of a quadratic. We're going to take a look at that on Desmos. So I've gone ahead and I've plotted that. And it asked me to add sliders for a, h, and k because those are the variables that will actually have numbers plugged in for them when we are doing our actual examples of equations. A is going to do the same thing that it did in standard form. Okay, if it's positive, the parabola opens up. If it's negative, the parabola opens down, and it changes how wide or narrow that graph is. So I'm just going to let that stick at 1 for right now. Get it on 1. There we go. So H and K, if you notice as I move H, our graph is going to move left and right. Okay. So really what we can focus on is the left and right movement when we look at H. K, when I move K, it's going to move down and up. So let's pick some specific examples. So let's put we'll put K at 3, and we'll put H at 6. And you'll notice that our vertex then over here is at 6, 3. But think about what our equation would be. Our equation, if I actually type out those variables, y equals was 1, a was 1, and then the quantity x minus h, so x minus 6, the quantity squared, and then plus k, so plus 3. And that landed right on top of that other graph. So what I'm trying to point out to you is when it was x minus 6 here, our graph moved to the right 6. And when it was plus 3, it moved up 3. Okay, let's do another example. What if I move the h over here to a negative number? So let's say h was negative 8, and let's say k was negative 5. So in that case, think about what my equation would be. Y equals 1, we didn't change our a value, x, and remember it's x minus h. Well, h is negative 8. So I could put in here x minus negative 8, but we know the same thing as x plus 8. So x plus 8, that quantity squared, and then my k value, that's minus 5. So when we have x plus 8, our graph moved left, and then the minus 5, it moved down. So basically, what you see inside the parentheses here, if it's positive, if it's plus something, it's going to move left, and if it's minus something, it's going to move right. So it kind of goes the opposite direction of what you think. But then the plus k on the outside, whatever k is, if it's plus k, it's going to be moving up, and if it's minus k, it's going to be moving down. So on our notes from the video, we learned that h and k give the vertex of the parabola. So the vertex is hk when you have the equation y equals a times the quantity x minus h squared plus k. Is the constant at the end of the function the y-intercept like it was in standard form? No, because it's the y coordinate of the vertex instead. And does the a value work the same way in vertex form as it does in standard form? Yes, it does. So I want you to pause for a second, and I want you to answer questions 1 and 2. Tell me, where is the vertex? And tell me, is that vertex going to be a minimum or a maximum? So for number 1, we have inside the parentheses x minus 3. Since it's minus, that tells us it moves right, 3, and then the plus 7 at the end moves up 7. So the vertex is at 3, 7. The negative 2 at the beginning tells us our parabola opens down, so this parabola has a maximum value. Number 2, x plus 5 in the parentheses means it's moving left 5, and negative 1 at the end means down 1. So your vertex is at negative 5, negative 1. And then because our a value is positive, that is a minimum value. Now, if we wanted to figure out what the y-intercepts were for each of those, we could go through and try to find that by plugging in 0 for x. So if we plugged in 0 for the first one, 0 minus 3 we know is negative 3, squared we know is 9. 9 times negative 2 is negative 18, and negative 18 plus 7 is negative 11. So our y-intercept here should be at negative 11. And then for the next one, 0 plus 5 is 5, squared is 25, times 3 is 75, minus 1 is 74. So then you could go back onto Desmos and check both of those. And you can see I have both of them graphed here, so I can turn them off over here. So if I click this one off, I'm only looking at the first one. I can see from my graph down here that it has a y-intercept down here at negative 11. Remember, I could also turn these into tables, and that's actually going to help me on the next problem, turning these into tables to fill in the tables on the back of your worksheet. So go ahead and do that real quick. So you can see right here that we have that completely finished.